The only word is identity. It's on the front page. First word. So go and write it down with me in identity. Watch this now. An equation, here we go. An equation, that's all we've been doing the last week, is equations. But now an identity is an equation with an infinite, imagine never ending, an infinite amount of solutions. Earphones off, goes away to further lecture. An equation with an infinite amount of solutions. So the one that Nava did for warm-up had one solution, and that solution was 6, if you remember, for the warm-up. There was only one number that satisfied the equation, it was 6, and he got it right. But now I'm talking about an equation with an infinite amount of solutions. In other words, an equation where any number would satisfy, any number you can think of. Let me give you an example. Write this with me. X plus 2 equals x plus 2. X plus 2 equals x plus 2. This would be an example of an equation with an infinite amount of solutions. Let me demonstrate. You just do one demonstration with the first one I'm going to put in, but I'm going to use guinea pig numbers, just any numbers we could think of, like our favorite numbers. Sepulveda, what's your favorite number? Watch this. I'm going to use Sepulveda's favorite number. That should be a solution. Let's see. I'm going to replace x with 5. Look at this. Is 7 equals 7? Absolutely. It checks. 5 satisfies. Florence, what's your favorite number?
1400.
14.
Okay. Watch this. Watch this. Florence's favorite number, 1400.
Equals 12, because that's my other favorite number too.
It's not going to equal 12. Look what's going to equal. It's going to be 1402 equals 1402, but my point is it satisfies. In other words, any number you can fathom would be a solution to the equation. In other words, it has an infinite amount of solutions. Not just one solution, infinite. The one that Nava did for warm-up had one solution. That solution was 6. Look, it was right here. This one, remember? There it is. Q equals 6. There's only one solution. That was it. No more, no less, just one. Now, infinite. Now, how do we solve equations like this? Flip the page. We're going to skip this part. Flip the page. You'll see 5 steps there. You see this? Go to flip the page really quick. It says steps for solving linear equations. Linear equations are just equations we've been doing. Okay, don't worry about the word linear at this point. All the equations I've been throwing at you since we started this quarter have been linear equations. Now here's how to solve any of them now. It's actually 5 steps instead of 2 steps. The last 2 days we've been doing 2-step process, but now I'm going to give you equations on steroids, so to speak, where the variables on both sides now, not just one side, where you'll see variables on the right and you'll see variables on the left. Here's what we do. Step 1. Contreras, can you read step 1 for me? Nice and loud.
Use the distributive property to remove any grouping symbols.
We already know how to do distributive property. We practiced that last week on assignment 2. Beautiful. Mr. Rojas, can you read out loud step 2?
Simplify the expression on each side of the equation.
Nice. We've been simplifying for the past 2 days. Mr. Nava did a lot of simplifying for the warm-up. Step 3. Flores, can you read step 3 for me? Read yours, man. It's right in front of you. It's on the other side. Step 3. You're the man. You're the man, Flores.
Variable term on one side of the equation. And
Constant.
constant.
Nice. Collect the variable terms on one side and the constant terms on the other. So on your notes, I want you to underline constant and put a little parentheses underneath. That's just a fancy word for numbers. Go to write numbers, just normal numbers. Put numbers. On your notes, go to write numbers. That's just a fancy word for a constant. So not step 3 that Flotus is read says collect the variable terms on one side and of the equation and the numbers on the other side. Ms. Mendez, can you read step 4? Isolate the variable. We know what isolate means. It means get by itself. We're rocking and rolling. Ms. Mendoza, can you read step 5? Check your solution. Now, step 5, check your solution is optional. Go to put a parentheses and write optional. You don't have to do step 5. Step 5 is optional if you don't trust yourself. If you doubt yourself, you doubt your skill that you got the right answer, the right solution, go ahead and check your solution. So that step 5 is optional. Now, we give you one equation, and we're going to demonstrate all 5 steps with one equation. So in this note section right here, let's do one equation. Here we go. Let's do it. Here we go, here we go. So I'm going to write example 1. So right underneath this, the 5 steps, we're going to do one example. Right, Flotus? Phone's away. 10 minus 4x equals negative 9x.
How many are we doing?
2.
2?
We'll do one right here and one on the right, and we're done for the day. Now, stay with me. Phone away. Earphones on. Okay. Just looking at this one equation right here, what's different about this equation as opposed to all the ones we've been doing up till now? Rojas. Right. There's x on the left, x on the right. For up to this point, we have not done any equation with x on both sides. That's why we have 5 steps now, because we have to deal with variables on both sides. So pay close attention, focus now. Let's do it. Step 1. Ms. Penny, can you read step 1?
Use the distributive property to remove any equivalence.
Does anybody see parentheses here?
No.
Nice. So step 1's done. Beautiful. Check that puppy. Benitez, can you read step 2? Okay. So step 1, I don't have to do it. It's done. Step 2 is, can I simplify the left side? Can I simplify this crap?
No.
Why? Argument. Perfect argument. How about the right side?
Yeah.
No. It's only one term. Good try. No, no. Step 2 is done. Check that puppy. So far, so good. It's an easy one. Let's go to step 3 now. Collect the variable terms on one side of the equation and the numbers, that's the constants, the numbers on the other. So we want to get on one side variables and the other side just numbers. That's what the goal is now for step 3. Stay with me. Here's what we're going to do. Flotus, help me out, man. Here we go. Focus. What I'm going to do now is I'm going to do something to both sides of the equation to get variables on one side. What I'm going to do is I'm going to add a 4x to the left. Remember, whatever I do to one side, I got to do the other. That's the addition property of equality. We learned that last week. We learned 4 properties of equality: adding, subtracting, multiplying, dividing properties of equality. This addition property of equality allows me to add something to both sides of the equation, anything I want. So let's do this. Hold up. What about here? Negative 4x plus 4x? That's 0. I got a 10 equaling. Let me talk, please. Thank you. I got a negative 9x plus a 4x. Signs are different, so I'm going to subtract, take the sign of the bigger number. In this case, it'll be a negative 5x. Flotus, let me talk to you outside. I'll be right there. You're the man. I appreciate you, man. You're awesome. Well done. I'll be there shortly. Now notice what we've done. Step 3, we've accomplished it. The variables are on one side, the numbers are on the other. Perfect. So step 3 is done. Step 4, we already know we could do this in our sleep now. Isolating variables. That's all we've been doing. Let's get x by itself, so we got to get rid of negative 5.
Right.
Nice, because that's opposite of multiplication. We're rocking and rolling. Here we go. Boom. Negative divided by negative is positive 1. X on the right is by itself. Beautiful. There's our solution. So this equation has one solution, not infinite amounts. We're just one. Cool. Let me give you another option now. So we did all 5 steps. We got x by itself. Cool. What I want you to do on your notes is put a little squiggly line from top to bottom and rewrite the equation again. And I'm going to show you an alternative way to see if you like the alternative way. So I'm going to write the same equation. 10 minus 4x equals negative 9x. So tomorrow I'm going to the Dodger game. I can go to the Dodger game, Dodger Stadium in downtown LA. I can take the 60 freeway to the 5, get off on Broadway. Or to get to downtown, I can take the 10 freeway, get off, take the 5, get off on Broadway. The 10 and the 60 go straight to downtown. They meet in downtown. In the same way, we're going to get to x equals negative 2 downtown, but a different route, a different route, different path. I'm going to show you a different path, and you tell me if you like this path as opposed to this one. Doesn't really matter which one, they both get to the same downtown destination. Watch this. On this one, I added 4x to get x's on the right. Look what I'm going to do here. I'm going to add 9x to both sides. Do this with me. Again, I'm on step 3 now, because remember step 1 and 2 you wouldn't have to do. I'm getting the variable terms on one side. Watch this. Let me bring down the equal sign. What is negative 9x plus 9x?
Yeah.
Awesome. 0 on the right. Look at that. It's kind of funky, but it's okay. You can have 0 on the right. Negative 4x plus 9x is going to be a positive 5x, notice. It's positive, notice. And I got the 10 floating on the left. We're still not done with step 3 because we got to get the number terms on one of the sides. Let's get the 10 on this side. How would you get the 10 on the left side? Or on the right side, rather, right? It's on the left. How do we get it over here? Right, let's subtract 10 from both sides. Look what happens. I have a 5x equaling, if you take 10 away from 0, what do you have? Negative 10. 0 minus 10 is negative 10. Now we're on step 4. Compare the step 4 here with the green step 4. Here we had a negative 5x equals 10. Here we have a 5x equals negative 10. It's like swapped. But the solution will still be the same in the end. Watch. I'm going to divide by 5. X is negative 2. Same thing. Negative divided by positive, negative. Here, x is isolated on the left. There, x is isolated on the right. Same solution. We're rocking and rolling. Okay.